This last strategy video is on the ×7. Now, if you've gone through a progression and learned about the commutative property, you will have already covered all the other facts. The only fact we'd have left is 7 × 7. Now, I know for myself, my experience talking with students and doing math running record, that the number 7 looks pretty scary to them. So when I ask them which problems seemed tricky today, they inevitably tell me addition, subtraction, multiplication, division, the ones that involve a 7. So I think it's a tricky number for their brain, but only because they're not familiar with exploring it. Once it becomes familiar, it will no longer look tricky to them. And the really powerful relationship of a ×7 is it can get broken apart into 5 groups and 2 groups. So the foundational facts of 2, 5, and 10 and the 1 group are so important because I can use those foundational facts to figure out the ×7. I don't have to skip count by 7s, which is relatively difficult to do. Particularly if I'm doing 8 or 9 groups of a 7 and I'm trying to skip count by that 7. So anytime that I have a 7, one way I think about it is I could do 5 groups and 2 groups. And again, if we reiterate that ×5 as being half of ×10, crazy powerful. Let's take a look at what this looks like when we have some visual images. So here is a visualization of 4 groups of 7, like 4 × 7. I also can think about it even with the same visual as 7 groups of 4, if I want to think about it vertically. So my choice here, 4 × 7, I might think about doubling the 7 and doubling it again. That is one way. But the ×7 does tend to look tricky a lot to kids. And if they're wanting to just skip count by 7s, it's a hard thing to do when you're skip counting by 7s, particularly if you don't have any additive reasoning and you're just counting on 7 each time, one by one, right? So let's just take a look at this array here of this 4 by 7. And what if I just change the color of these? So let me just change that to yellow. Now, what do you think about this? Right? We can see that it's a 4 by 5 array. So this piece of it is worth 20. And then I have 2 more 4s, which is 8, which of course makes our total of that 28. That might be more accessible to some students than the doubling. It's a matter of their choice, and they're owning these strategies and the heart of this distributive property to break apart factors in ways that are easier for our brain. And the foundational facts, if we do those first, the 2, 5, 10, and a 1, we can derive any other math fact, those higher ones, using those foundational facts. So rather than going through a sequential order, let's go to those foundational facts first. Now, visually, I want to show you just one more way. So here we have Cuisenaire rods again. And again, we have this math fact of 7 × 7. Right? So let's take a look at this. Now, I have not separated it to tell how many are there at a glance, but what if I do this, right? So I might certainly show all these 7s and ask a student, is there any math facts of 7s you know for sure? And if maybe they know that 7 × 6 is 42. I could then work with them to see one more group makes the 7 7s. But a lot of our students do get their ×5s and ×2s relatively easier than the other facts, those foundational facts. And we can capitalize on using the 5 and the 2. Really powerful way of being able to multiply anything by 7. We can figure out the ×5 and then the doubles. And again, the ×5, we can do half of the 10 groups. It's really, really powerful and has such a positive future impact on their math journeys as well.